This is Lab 7 by Chelsea Sizemore. The main objective of this lab was to calculate the mass of the black hole using Newton's second law of gravity with the star's orbital motion. The result is the mass of the black hole can be calculated based off of what is given, using the gravitational law and the position of the star's orbital and the net forces. To do this, we made a code in Python, and we had the star's mass as 1.989 e to the 30th. We have the gravitational constant, which is 6.67 e to the negative 11th, and the delta t, which is a day in seconds. Then we imported the Excel spreadsheet of the star's data, which is from the WebAssign, and we changed the code so that it would calculate the mass of the black hole. As you can see, the black arrow represents Fnet, and the blue arrow represents the Fnet parallel, which is a change in magnitude, and the red arrow represents Fnet perpendicular, which is a change in momentum. As you watch the arrows going around in the orbital, the Fnet is always pointing at the black hole, which would be around where my mouse is, and the perpendicular and parallel arrows are always pointing in the same direction as well. When everything is calculated, it shows that the mass of the black hole would be 3.82 e to the 31. What does this mean? How do delta p over delta t relate to delta p over delta t parallel and delta p over delta t perpendicular? Delta p over delta t parallel and perpendicular forces equals Fnet. And we know that, as I wrote the equation down here, that Fnet equals Fnet parallel plus Fnet perpendicular. And since we know delta p over delta t equals Fnet, that means that Fnet parallel is equal to delta p over delta t parallel, and Fnet perpendicular is equal to delta p over delta t perpendicular. To prove this, I printed out the code, and it shows that Fnet is the same, 3.06 e to 26, as delta p over delta t, which is also 3.06 e to 26. And Fnet parallel and delta p over delta t parallel is the same. They're both 1.35 e to the 26. And the Fnet perpendicular and delta p over delta t perpendicular are the same as well at 2.7 e to the 26. But the Fnet and delta p over delta t are a little bit different, because even though Fnet and delta p and delta t are equal to each other, they're not exactly the same, because Fnet is a force causing the change, and delta p over delta t also causes change, but it is what we're actually observing. We're not observing Fnet. What if? Imagine the black hole whose mass you found was replaced by a different black hole, but is still placed at the same location. Assume the motion of the observed star remains unchanged and is affected only by the gravitational force of the new black hole. Could you tell the difference? Yes, you could tell the difference, because mass is proportional to gravity. If the mass of the new black hole was different from the old black hole, we could tell by the changing gravitational pull of the star's orbital that would be calculated.